Morning, students. Yesterday we learned balancing equations, and the complete outline of what we are going to learn in this first chapter, outlook of the first chapter. That means balancing equation, types of chemical reactions, corrosion and rancidity. So yesterday part we learned only balancing equations. Am I right? I hope all of you have done your worksheet, and most of the students are responding me by sending the worksheets. That's very good. And in this video what we are going to learn is we are going to learn on types of chemical reactions. Okay, types of chemical reaction. How many types of chemical reactions are there? So we have actually 5 different types of chemical reactions that we are going to learn in this class. One is combination reaction, decomposition reaction, displacement reaction, double displacement reaction, and oxidation and reduction. Okay, combination reaction. Okay, let's go one by one so that we learn better on these topics even easily. Combination reaction. Okay, all of you take your book and turn to page number 6 in your book, 1.2.1 combination reaction, and there is an activity which is given there. You can look at that activity, and if you have a time you can read that activity now or you can read it later. Okay, that activity talks about we should take a beaker and add some water in that and add calcium oxide. You know, calcium oxide is nothing but a quicklime. In Hindi you name them as chuna, right? When calcium oxide is added inside the water, immediately, and when it mixed completely, you will see the color changes and it turn into calcium hydroxide. That means calcium oxide turn into calcium hydroxide. Not only that, and we can see enough amount of heat energy will also be generated. Okay, let's move on to what is actually combination reaction. Combination reaction is when two or more substances, that means it can be an element or a compound, combines to form a single product. You look at it. Here we have calcium oxide A combines with water B and gives calcium hydroxide. Let me give you an example so that you can understand more on what is actually combination reaction. So as you know that what is combination reaction? When two or more substances combine to form a single product. You see here, this is one substance. You think that this is one substance and this is another substance. It can be an element. I think that this is calcium oxide, okay, and this is water. When these two things combine together and they form a single product, see here, now it become calcium hydroxide, right? So this, if you look at here, before that it is actually 2. Now after combining they form a single product, and this is what combination reaction. I can give an example like A plus B gives AB. That means two different types of an element or a compound combine to form a single product, and this is what said to be a combination reaction. Let us give some more example on combination reaction so that you will understand more on what is actually combination reaction. I give you one more example. You look at it. Hydrogen combines with oxygen, it's a simple one, to give water. It's not balanced actually, and it's your duty to balance it. How we can balance? We have 2 hydrogen, here also 2 hydrogen, 2 oxygen here, and only 1 oxygen. To balance, I put 2 here in front, and now hydrogen becomes 4, so we have to put 2 here to balance now. So now it's balanced. Look at here, 1 in the that means one element plus another element, two elements combine to form a single product. That's what the definition talks about. When two or more substances, that means element or a compound, combines to form a single product. When two or more substances combine to form a single product is said to be a combination reaction. I hope you all understand this. Okay, I can give you one more example. Remember the example that I gave you yesterday. Magnesium plus oxygen gives magnesium oxide. That means two or more elements combine to form a single product. Clear? So, and you have to balance this. Understood? So this is what combination reaction. So in combination reaction itself, what we are learning actually, you look at here, two elements combine to form a single product. Okay, well and good. And here in this equation, calcium oxide combines with water to give calcium hydroxide. That means quicklime combines with water and becomes slacklime. Along with, you see lots of heat energy is also evolved. Heat energy evolved. What it means? When heat is evolved or released, then it is said to be an exothermic reaction. What is exothermic reaction? Exothermic reaction is nothing but whenever there is a heat energy comes out during the chemical reactions, and that is said to be an exothermic reaction. Take an example, this calcium oxide, after putting that something in water, it produces lots of heat energy. That means this is also one of the exothermic reaction. Clear? Right. What are the examples of exothermic reaction? Here I have given one example. You look at it. When methane is react with water, oxygen, it gives carbon dioxide and water. That means all these, look at here, these are the states of these elements or compound. All these are in gaseous state. Methane gas, oxygen gas, carbon dioxide gas, water. It's also not a water, actually it's a vapor. Okay, it's in present in the gas. So heat energy is evolved. And some more examples, respiration is also one of the exothermic reaction. Even decomposition of vegetable matter into compost, and that is also one of the exothermic reaction. You can see these things in your book and page number 7. You can go through that. You can see a clear view of it. Some of the examples are given here of exothermic reaction. Okay, what is the opposite of exothermic reaction? It is endothermic reaction. Endothermic reaction. What is endothermic reaction? Here heat is evolved, that means comes out, released. Endothermic means heat energy is absorbed. Okay, so you write it ahead. Heat is absorbed. Heat energy is absorbed, and that is said to be an endothermic reaction. Let's give one example for that. We move on to the next topic, decomposition reaction. A decomposition reaction, here we are going to learn decompose. What is decomposition reaction? As we know, combination reaction is two or more substances combined to form a single product. So we saw an example like this, and two more substances combined to form a single product. But in decomposition reaction, this is a single reactant. You look at here, single reactant decomposes to form two or more. That is what the definition talks about. Single reactants break down to give simplest product. That means single reactant break down to give simpler substances. For that, we are going to learn an example of ferrous sulfate. What happens when ferrous sulfate is burnt? Let's see an example here. ferrous sulfate is a pale green color crystals, small green color crystals. And what we are going to do, we put some crystals of ferrous sulfate in the test tube, and simply we are going to heat it, right? When we heat ferrous sulfate, that means ferrous sulfate is FeSO4, and they have lots of water molecules also along with ferrous sulfate. That means 7 molecules of water molecules. So when we heat, what will happen? This water molecules gets evaporated. Am I right? So ferrous sulfate, hydrated ferrous sulfate becoming dehydrated. Will you all understand? Ferrous sulfate, hydrated ferrous sulfate become dehydrated. And not only that, this ferrous sulfate, when it is getting heated, it becomes ferric oxide. What it becomes? Ferric oxide. And also sulfur dioxide and sulfur trioxide gases will comes out, releases out. Okay, this is a pale green color, as I told you. Ferrous sulfate, a pale green color. When it is heated, it becomes dehydrated, so it leaves only ferric oxide. Ferric oxide is nothing but a rust. So what is the color of rust? It shows some light brown color. And sulfur dioxide and sulfur trioxide, even the smell you can identify the smell of a sulfur, right? So this is an example of thermal decomposition reaction. So decomposition reaction itself, we have 3 different types of decomposition reaction: thermal decomposition, photo decomposition, and electric decomposition. So what we are learning now is thermal decomposition. That means through heating, by heating ferrous sulfate, it turned into 3 different products. You see that ferrous sulfate is single actually. Ferrous sulfate, only one compound, right? But when it is heated, it becomes 3. 1, 2, 3. You got it? So that means ferrous sulfate, after it's heated, it becomes ferric oxide, sulfur dioxide, and sulfur trioxide. Can you understand? So this is an example of thermal decomposition reaction. We'll have one more example also, that also we will write it here. Okay, an example of lead nitrate, PbNO3 twice. When it is heated, it become lead oxide plus this is nitrogen dioxide and then some amount of oxygen gas. You know what happens? This lead nitrate is actually a white color crystal. When it is heated, it leaves, as I told you, all these crystals have moisture in that water molecules are in that, so they get evaporated first and it becomes lead oxide. Lead oxide is in a yellow color solid substance which is formed, and this nitrogen dioxide, you see a brown color, reddish brown color gas which is comes out through this, right? This is a gas comes out, reddish brown color gas which is comes through this, and that is nitrogen dioxide and oxygen comes out. You look at it, the same thing, same procedure. Thermal decomposition reaction, single reactant, when it is heated, it breaks down into 3 different products. See, 3 simpler products, right? This is one example of thermal decomposition reaction. Do you all understand? Let's move on to photo decomposition reaction. Photo, it means, you know, there is a light. Photo means light. Okay, here light, it's sunlight. Okay, we'll give an example of silver chloride. Silver chloride color is actually a white color silver chloride. You just keep some white color silver chloride in a china dish or in a watch glass and exposed it to sunlight, and just keep it outside in a sunlight. After some time, you need not to heat or you need not to add some water, nothing. Just add silver chloride in a watch glass and keep it outside in a sunlight. That's it. Immediately, slowly, there is a color changes. Silver chloride color turn into a gray color. That means it turns gray if you keep it in a sunlight. Why it is turned gray? Because it remains silver inside, and all the chlorine molecule which is present inside, they goes out. It means they get decomposed. In other words, they gets out. So you can look at it. This is also a decomposition reaction. Single reactant. After the reaction gets over, you see that we get two different products. One single reactant becomes two products, right? Decomposes. You know what is decomposition? Decompose of a rat. If you see a rat which is died on a road, after 2-3 days, you can't see a complete rat there, right? They decomposes. They break their body into pieces, and then you can see legs comes out, and their the eyes comes out, and their all these are just decomposes. This is what actually decomposition. That means one single product is break down into many pieces, and that is what decomposition reaction. Here also what happens here, a single reactant breaks down into 2-3 products. Okay, let's give one more example. We'll give an example of silver bromide. After keeping it on a sunlight, again it turn into silver and bromine gas. Same thing, same procedure. Just keep it on outside a sunlight, and it turn into a brown color. And this is actually given in your book in page number 10. You can look at it, and you can see this silver bromide is also behaves the same way when you keep it on a sunlight. And this equation is one of the reaction used in the black and white photography, right? And this is one of the example for that. And this, you see that we have seen this decomposition reaction requires energy in the form of light, heat and electricity for breaking down the reaction. So the reaction in which energy is absorbed is known as endothermic reaction. So you know what is endothermic now. So all these decomposition reaction, it's not we are not it is not taking place just like that. We are doing something. That means especially we are heating it. After absorbing the heat only, this reaction is taking place, right? It's not like combination reaction. Combination reaction, we are not heating it. You look at it, calcium oxide, just put it inside a water, you will see a calcium hydroxide. We are not heating anything. Even the breathing, the respiration, we are not doing any heating at all. But heat energy comes out. That is exothermic reaction. But in endothermic reaction, only after heat is absorbed, then they will give a product. You see the thermal decomposition reaction, after absorbing the heat energy, it breaks down into 3 pieces and then gives an energy, a product. Here also photo decomposition reaction, after it is absorbing sunlight, that heat energy, and then only it breaks down into 2-3 products. Here we are going to learn on electric decomposition reaction. What happens? Just take some water, and it looks like this. You can look at this picture in your book and page number 9, electrolysis of water, and you see what happens. They connected 2 electrodes in a mug, and they pour some water in this, and you see that both the electrodes are connected with a battery. One is with positive, another with a negative, right? In both this, they put some test tubes, inverted test tube inside that, and you see bubbles are all coming out. What is this reaction? This reaction is like this. Water, after passing electricity, you know what happens? Hydrogen and oxygen comes out. Hydrogen is positive and oxygen is negative. So if it is positive, then it will go towards negative terminal, and this is negative, and it will go towards the positive terminal of the battery, right? So, and here hydrogen bubbles are all coming out, and so for example, this is connected with positive and this is connected with negative in a battery. So hydrogen, which is actually positive in charge, they go towards negative terminal. So here hydrogen bubbles are all coming out, and this is oxygen is negatively charged, and this will go towards the positive terminal. So you can get oxygen gas comes out from this positive terminal. Will you all understand here? So this is also one of the decomposition reaction. You see, one single reactant breaks down to become two similar products. Will you all understand this? This is electric decomposition reaction. So what we learn now, decomposition reaction, one is thermal, photo and electric decomposition reaction. You can take down these equations and then do it once again in your home, right? Do 2-3 times and then you will understand more on decomposition reaction. Okay, the next type of chemical reaction that we are going to learn is displacement reaction. The definition of displacement reaction is very simple. The high reactive element displaces the weak reactive one. It's very simple. You can even try this activity in your home also. For example, iron. Iron is a more strong element comparing copper. So what is an activity? We can take a beaker, or a test tube, add some copper sulfate in that. Copper sulfate is blue in color, so we know that, and add one iron nail. Take an iron nail, rub that iron nail with the sandpaper so that it removes all the rust which is on the top of the iron nail, and then after cleaning it, you put it inside the copper sulfate solution. Okay, wait for some time, or you can add 1 or 2 drops of even sulfuric acid to make this reaction even more faster, right? It acts as a catalyst, right? So what happens after some time, you will see this iron nail is covered with brown coating. Iron nail is covered with a shining brown coating, and then the color of copper sulfate is turned into a pale green color. Remember pale green color? Just now we talk about pale green color. What is actually pale green color? Yes, ferrous sulfate. So what happens here? Copper sulfate, the blue color copper sulfate turn into a pale green color. How this green color comes and why there is a brown or a shining brown color coating comes on the top of iron nail? Let's see with this example. Iron react with copper sulfate, it turn into ferrous sulfate and copper. Why I can give an example like this. If even a tall and a healthy boy, we can name him as a iron, okay, and this copper sulfate, okay, you think copper is a very lean boy, okay, now he is attached with sulfate. He is having a good friend called sulfate. So lean boy is now having a friendship with the sulfate. You think of that, this iron is a very fat boy, very healthy boy. He can come and throw this small lean boy outside, and he can go and stick with this sulfate. Am I right? It's very simple for a fat boy to do. So what happens? So iron can come and join with sulfate, and what about the copper? Copper goes out. Will you understand here? I can give one more example like this. This is an iron. You see, it's little bigger, tall, and this is copper, and copper is now attached with sulfate. Now what the iron is doing is stronger. You see that it's stronger than copper, so it throw the copper away, and now it will attach with the sulfate. So now it become iron sulfate. And where is the copper now? Copper is here outside. Do you understand this? Iron sulfate and copper is displaced. This is what the meaning of displaced, that the place changes. Clear? Let's try with one more example of a displacement reaction, like an example of zinc with copper sulfate. As we know, the reactivity series of metal, zinc is more reactive than copper. So same thing, what happens, zinc is also positive, copper is also positive, and this is negative. Zinc will go and sit with sulfate, so I can write it as zinc sulfate. And what about the copper? Thrown out. Clear? This is an example of a displacement reaction. We can write one more example also. Lead react with copper chloride, and what happens, lead is more strong, so it become lead chloride plus copper. Understood? So these are some examples of a displacement reaction. Let's move on to double displacement reaction. Double displacement reaction is, it's another way I can say that exchanges of ions between the reactants are called double displacement reaction. So what they do, they exchange their ions. How they exchange an ion? Take an example, sodium sulfate, barium chloride, it turned into barium chloride, sulfate, and sodium chloride. You see that sodium, which is having positive in charge, it's a metal actually, and sulfate is non-metal. Barium metal, chlorine is a non-metal. So this positive, they need negative, right? So they stick with this, they form sodium sulfate. So now this reactants are going to going to react together. These two are going to react. So how they react? This positive, they will go and stick with this negative, because they are reacting together, and this positive will react with this. That is what happened here. Barium sulfate, always we used to write positive always in the front, so write it as barium sulfate and sodium chloride, right? And in this reaction, you know what happens, barium sulfate is precipitated. You remember this arrow mark, as I told you before in the first video, it means precipitated. What is precipitation? It looks like this. I am going to take a one test tube. In this I have taken sodium sulfate. Another test tube, I'm going to take barium chloride, okay, BaCl2. These two actually, sodium sulfate and barium chloride, these two are going to be mixed together. After they mix together, you know, it turned into this barium sulfate, it turned into a solid substance. It get precipitated and comes down and settle at the bottom of the test tube. Once they both reacted, you know what happened, they exchanged their radicals, and then so barium sulfate comes down and settle at the bottom. This is precipitated. Which is precipitated? This barium sulfate is precipitated. What is actually precipitation? Precipitation is nothing but insoluble substance which is formed insoluble substance. This barium sulfate is formed as an insoluble substance, and that is called said to be a precipitation. In precipitation, you know, even it never dissolves even in a water. That is actually precipitation. Clear? So which is precipitated in double displacement reaction? Barium sulfate. Clear? And sodium chloride is remain on the normal salt water. The next topic we are going to learn here is oxidation and reduction. I just go a little faster. Oxidation and reduction. Oxidation, it means addition of oxygen or removal of hydrogen. Either oxygen add or hydrogen should be removed. There is another definition for oxidation. It is loss of electron. Electrons, they lose some electron, then that is also oxidation. Reduction is addition of hydrogen, just opposite of it. Addition of hydrogen or removal of oxygen. In other words, just opposite, gain of electron. So this is what oxidation and reduction definition. Okay, let's give an example here. We'll take an example which is given in your book. An activity is there. You can check this activity. Figure 1.10, 1.2.5 oxidation and reduction. Take a china dish and add some copper. You know what is the color of copper? It is actually it's shining, brown color one. And you know what happens after copper is heated? You can see after copper is heated, it turned into a black color substance. This black color is nothing but copper oxide. Check this. When copper is heated, it turned into copper oxide, and this become black in color. This copper oxide, once we pass hydrogen gas on a copper oxide, it turn into again copper, and water will be removed out. That means it come back again the same. So copper heated, it become a black color copper oxide, and after copper oxide we pass some hydrogen gas on it, it turned into copper back, and hydrogen water and the water molecules. So what we are learning from this is copper oxygen is added and they form copper oxide. This is what oxidation reaction. Copper, after adding oxygen, it becomes copper oxide. This reaction, or this, is said to be an oxidation reaction. And you look at this copper oxide, and here hydrogen, after passing hydrogen, the oxide which is present with the copper is removed. The oxygen with the which is present with copper is removed, and that is why it's said to be a reduction reaction. You understand that? Copper के साथ if you add oxygen, it become oxidation, and the removal of oxygen is said to be reduction. Addition of oxygen is said to be oxidation. Removal of oxygen is said to be reduction. Okay, what happened when these two, oxidation and reduction, takes place simultaneously together? If these two reaction takes place at the same time together, then that kind of reaction are said to be oxidation reduction reaction or redox reaction. Okay, how can I write like this? I can write like this: copper oxide react with hydrogen and just heat it, it produce copper and water. That means you look at it, copper they have oxygen with them, and now you look at it, copper oxide is reduced to copper. Why I say reduced? Because oxygen is removed. Copper oxide, they have oxygen with them, and it is removed out, right? Reduction. And hydrogen, you look at it, there is no oxygen with the hydrogen, but here look at the product, addition of oxygen takes place, so it is oxidation. Do you all understand here? Okay, let me give you one more example. MnO2 plus 4HCl gives MnCl2 plus 2H2O plus Cl2. You can see the same reaction is given in your book also. And MnO2, that means manganese dioxide, is having oxygen with them, and it is turned into manganese chloride, right? Manganese chloride, that means the oxygen which is manganese dioxide is having is removed. So what is this? Once oxygen is removed, we name them as a reduction reaction. And look at this hydrochloric acid, and there is no oxygen with hydrogen, right? That means even there is a definition, we name them as addition of oxygen or removal of hydrogen. You look at this chlorine, they have a hydrogen with them, and now compare this now with chlorine. Hydrogen is removed. Am I right? You look at this in your book. I'm going to show this in page number 13. In this reaction, carbon is oxidized. Okay, not this one, the second one. Hydrochloric acid is oxidized to chlorine, whereas manganese dioxide is reduced to manganese chloride. Right? So hydrochloric acid, hydrogen will be removed. That means a removal of hydrogen takes place, and so that is also said to be oxidation reaction. So I write it here as oxidation reaction. Understood all of you? What is oxidation and reduction? I'll give one more example. So we learn what is addition of oxygen, removal of hydrogen, addition of hydrogen, removal of oxygen. Let's learn how this loss of electron or gain of electron takes place. Let's take an example of sodium combined with chlorine to give sodium chloride. You know how this sodium and chlorine combine to form sodium chloride? Sodium is actually, it's a metal, right? The electronic configuration of sodium is 281. That means atomic number is 11. And chlorine, it's 287. That means chlorine needs to give one electron to someone. That means it should lose electron, and chlorine should gain some electron. Then only they can combine. See, there is no charge here for sodium, and there is no charge here for chlorine. Both have zero charges. But after this, after sodium loses one electron, they become Na plus. That means their electronic configuration only is 2,8. And chlorine, after gaining one electron, it becomes 2, 8 and 8. Clear? Before it is 2, 8, 7. Now it becomes 2, 8, 8. Understood? So it gains one charge here. So what is actually, I'm going to tell you another thing, oxidation. Which one is oxidized? Sodium is oxidized. Why sodium is oxidized? Because it loses one electron. It loses one electron. Why chlorine is reduced? Because it gains one electron. You look at here, before it is 287, now 2, 8 and 8, gains an electron. You will understand now. So this is what oxidation and reduction. Clear, student? The last topic we are going to learn now is corrosion and rancidity. You know that corrosion is a process in which metals are slowly eaten up by the action of air, moisture or chemical. So say an example, sometimes you see black coating which comes on silver, black coating which comes on it. And on copper, you see a green coating on copper, and normally a brown coating comes on iron, a brown coating. And all these coatings are all actually a rust. These are all the rust. Clear? And how this comes? Because they are exposed in the air, moisture. Sometimes slowly they started eaten up by all these corrosion, right? And this is what actually said to be a corrosion, right? Corrosion, it damages most of the car bodies or bridges, iron railings, even ships. Everything is damaged by corrosion. So how to avoid corrosion? What we should do? We should remove this black color. How to remove this? Yes, we can polish it, right? Copper, we can rub it with sandpaper, and then we can paint it over them. Even iron also we can paint it. Galvanization process, we know that, right? And chrome plating, anodizing, so all these are the process we can do to avoid control these corrosion. Rancidity is when a substance containing oil or fat, for example, yesterday night you may prepare some chicken kurma or something, it's made up of oil substance, you can keep it outside and you forget it, keeping it inside the fridge or anything, but after one day, completely one day, or the next evening or night only, you're looking at, oh, you're not keeping it inside, you see that the smell changes completely, right? The taste also changes. You won't taste it actually, but the smell and the taste totally changes, the color changes. And why this is happening? It is because when a substance containing oil or fat are exposed to air, we are keeping it outside, it's exposed to air, they get oxidized and become rancid. This is what rancid means. The changes, the smell changes, the taste changes, the color changes, right? That means they get oxidized completely, खराब हो जाता है. That is what actually rancid. So we can give some more example. That is why if you go and buy some Lay's chips or all, the packets are filled with air. Air is nothing but they fill that packets with nitrogen gas. This nitrogen gas, what they do, it's not oxygen gas. If they fill with oxygen gas, only one day they get all rancid, but they fill it with nitrogen gas so that the chips is still prevent the nitrogen gas prevents the chips from getting oxidized. That is why they are putting some nitrogen gas on it. Okay students, hope you all understand this. If you have any doubt on this topics what we learned now, you please message me or send me some comment so that I try to change. And even if you have any doubt, you can please suggest, send your doubt so that I can clarify your doubts, right? So what we learned today, we learned types of chemical reaction, so combination, decomposition, types of decomposition reaction, displacement, double displacement, oxidation and reduction, and also corrosion and rancidity, right? So thank you so much, and stay in your home, don't go out, and I'll be sending some of these question answers also in this chapter, and you can go through this question and answers. If you have a book, you can go through all these question and answers which is given in your book. I'll be sending you some more questions along with that. You can study, right? Thank you.